Hello, and welcome to the CCNA Routing and Switching course offered by SimplyLearn. The previous lesson focused on IPv4 addressing and subnetting. This lesson focuses on VLSM, Summarization, and Troubleshooting TCP/IP. Let us begin with the objectives of this lesson in the next slide. By the end of this lesson, you will be able to describe the benefits of VLSMs, calculate VLSM IP addressing design to a network, describe subnetting a network, define summarization and switching, describe the switching process and routing, explain troubleshooting steps for TCP/IP. Let us first look at VLSM. Suppose a network uses a Class B network address where 16 bits are used for the network and 16 bits are used for the hosts. The network administrator should create 4 subnets. There are 65,536 2 to the power 16 possible addresses that are available to assign to hosts. Of these, 65,534 are usable addresses. But 4 subnets need to be created. Since 4 is 2 to the power of 2, borrow 2 bits. That leaves 14 host bits. All possible combinations of zeros and ones that could occur in the remaining 14 bits produce a total number of possible hosts that could be assigned in each subnet. This is 16,384 possible hosts, but only 16,376 usable hosts because 2 addresses are reserved per subnet. Let us look at some examples with Class C addresses in the next slide. In this topology, data exchanged between PC A and PC B is handled by the switch. Likewise, data exchanged between PC C and PC D is handled by the switch. But a router is required to route packets between the PCs on the left and the PCs on the right. Routers are used to route packets destined for non-local networks. The router FAOO interface is in the same subnet as PCs A and B, the 192.168.1.0/24 network. The other router interface, FAO1, is in the same subnet as PCs C and D, the 192.168.2.0/24 network. This brings up an important point. Each router interface is in a different subnet. Let us continue our discussion on routing in the next slide.